Okay, so Radhe Radhe guys, I think I am audible, right? Am I? Quickly, join. Yeah, from my end, it's showing that I am live, watching my own ad only. Let me quickly do one thing. Properly audible, huh? Okay, I'll just share this link with on Discord, and then I'll start with it. Okay, start with today's video because I'm expecting people to join. And if not much people join, I will just screen the first two only. I have the code for the third one, but uh, okay, yeah. If I find that at least apart from me one person is there, then I'll just start explaining the whole thing. Okay, seems like not much people are on today. I think today's code forces was difficult, or maybe I am giving a contest after a long time, so it seemed to be difficult to me. I don't know, but yeah, let's start. Okay, the first problem: A. Adjacent digit sums. What does it mean? You're given two numbers x and y. You need to determine if there exists an integer n such that s of n is equal to x and s of n plus 1 is equal to y. What is s of n? It is the sum of digits of the number n in decimal numeral system. You don't need to know what I mean. It's not about needing to know. It's very basic, right? Now, what you have to do is you have to tell that whether it is possible that there are two numbers x and y, and these conditions also satisfy for them. Okay. Now, how can you tell? Okay, so one more thing: x is lesser than equal to 1,000, and y is lesser than equal to 1,000. But remember one thing: even if it was not 1,000, then also there is also some other method to do it. Okay. Now, how to do it? Okay, how to do it? Let's mm, go to Excalibur. Okay. Now see, you have two numbers x and y, right? You have got two numbers x and y. Yeah, now it's visible. Now from these two numbers, what you can say is, let's say you can make a integer a for which the sum is x. Okay, and you have to find whether this condition satisfies or not, right? But you can't make any random value of a, right? You can't make it. But what is the most greedy approach to do it? Since you know that the value of the sum of everything is x, so the most greedy approach is to have 1 1 1 1 till x number of times. Okay, you can have it till x number of times. So in that case, like, you can get a basic gist of what it is all about, right? Now what you can do is, if you want to add 1 to any specific number, okay, over here, so let's say it is at the end, it is 1, right? Now if you want to add 1, so everything remains same apart from the last number, right? The last number becomes 2. So what does it mean? That the sum of that is x and y is basically 1 more than x. So we can say one thing very surely, that if y is more than y is equal to x plus 1, in that case we can directly say that it's a yes. Okay, thus coming with the first condition 1 2, and it's a yes. So now you know why, because if you're going for 1 2, it can be 1 2. Okay, Clear? Now about the other conditions. Okay, so let's say if it was 1 3, will it be a valid thing? Will it be possible? Can I add 1 to a number and increase its sum by 2? Is it possible? It is not possible. Now I'm going to give you a proof why it is not possible. Okay, see, over here I just discussed that if I want to increase the value of the sum, I can add 1 to it. Now for every specific condition, if I am adding 1 to it, it increases. Apart from the fact if the last digit is a 9. Okay, so let's say the last digit is a 9, then if you add 1 to it, so basically what happens is this specific position, it becomes 0, and the position before that 1 gets added to it. I think there is a lag, sorry. Yeah, let me do one thing, let me just explain it again because there was a lag. So when I'm adding 1 to the 9, this specific position, it becomes 0, and the previous position, it becomes plus 1, right? Now from this fact, what we can consider that, let's say the previous position is also 9. So in that case also this becomes 0 and the previous position becomes plus 1. Now you see one thing, that no matter whatever it is happening, over here initially there was 9 which becomes now 0, right? That is, it is reducing, and at any position it has reduced by minus 9. Okay, it is reduced by 9 at any position. No matter whatever you are adding, you can't make it plus 9. You can't neutralize this. You can never neutralize this and then just forget about making it more than that. So one thing is very much clear, that is, if x plus 1, okay, if y is greater than x plus 1, it is a no, right? Clear? So one thing that we can directly say, that if y is equal to, okay, let me just go with some cases. Okay, case 1, or rather, yeah, case 1. If y is equal to x plus 1, what is this case? Yeah. How many questions did you do, Arnav? So if y is equal to x plus 1, we can directly say that it's a yes. I just explained why. Second condition. What is the second condition? Let me just follow my screen. Yeah. So what is the second condition? The second condition is y is greater than x plus 1. The previous one was y is equal to x plus 1. Now is y greater than x plus 1. In this case, it's a no. I just told you why. Okay. I did too, don't know how. Okay. Hi, hi, hello, bro. Hello, hello, hello. Okay, so people are now watching it. Okay, yeah. No, man. Like, if you think that you're an idiot, then I'm also an idiot. Okay, because I just did too. And you can see that there are 4,384 submissions on C and 1,000 plus submissions on D. Now, it may be because I am doing CP after a long time, or maybe because like Telegram is more active these days. You never know. Okay, so let's go to case 3. Okay, so what is case 3? It is y is lesser than x plus 1. Okay, or rather, let's say, since you know that that it is y is not equal to x. Okay, so there is also another case I think I forgot to mention, that is, even if y is equal to x, then also it is not possible, right? Y can never be equal to x also. If you want, you can get the proof of it, because as I told you that if you're adding one, which college do you used to, I am presently doing like I am a pass out, yeah. So basically what happens is that if you're okay, so let me just do one thing. Instead of making the case 3 this, the case 3 is x equal to y. So in the first condition I explained you why uh, it is a valid condition if y is equal to x plus 1, right? And in the second case I explained you that no matter if you're adding 1 to it, the first condition will be satisfied only apart from the fact if the last digit is a 9. And if the last digit is a 9, it gets minus 9, right? It gets minus 9. But no matter how much you add to the previous elements, you can never neutralize that 9. Okay, so if you can't neutralize that 9, it was a wrong concept to make it more than that, right? I mentioned this. But if you can't neutralize that 9, then also it means that you can't make it equal. Okay, so if x is equal to y, not possible. Let's move on to case 3. I mean, sorry, case 4. Yeah. So what does case 4 tell us? Second one, yeah, even I was stuck on it for a long time. So what is case 4? That is, if y is lesser than x. Now it is possible. It is possible. How? I just mentioned that if the last digit is a 9 and you are adding 1 to it, this becomes 0, and over here we have a carry of 1, right? Now just think it this way, okay? Just think it this way, that there may be a series of 9s. Okay, there may be a series of 9s. You don't know how many. And after that, there is some other number, let's say 7, 8, something else. Okay. So till that series of 9, this thing happens that this becomes 0 and the previous becomes plus 1. Becomes 0 and the previous becomes plus 1. Was in 20 minutes but was not able to do. Yeah. So like this happens, right? There's a chain. Now if you notice one thing, the chain continues till the last 9. It becomes 0 and the previous element becomes plus 1. Right? So this becomes 8. Now, if you want to find the difference, okay, the difference of the first and the second number, I mean this number and this number, it is basically nothing but 9, all these 9s, okay, if you add up, let me use a different color. If you, no, not a good color. If you add up these numbers, okay, if you add up these numbers and you subtract them and then add 1, okay, add 1 to it. So that is basically the difference between the sum of this number and this number, right? So one thing that you can possibly make out from here is that by doing some arithmetical equations, so whatever is the sum of this, you don't know this number, okay, this number is unknown to you, you don't know this number, but whatever sum it is, let's say it is s1, which is x, okay. Now what is a valid value of s2? So let's say this is the sum of this. It is nothing but over here s1, if you add the 1, okay, add the 1 to it. If you add 1 to s1 and then subtract x number of 9s. You don't know the value, sorry, not x because x is already used. So let's say z number of 9s. You don't know what is the value of z, okay. You just know that there is a chain of 9, okay. It should be equal to s2. Now let's solve the equation. That is x plus 1 minus 9z is equal to y. So over here, you don't have to even consider what should be the value of z, right? But like you have to consider. I mean, I don't mean that you don't have to consider. But the most tricky part over here is that how can you find out what should be the value of this, right? How to find it out is basically more simpler. It is like if you solve the equation, it makes it 9z, right? Now you know one thing, that this z is an integer, right? Now the most important thing, you don't need to find out z. But since you know that z is an integer, it means that if you're dividing this by 9 and dividing this by 9, so this is also an integer, right? Now since this is an integer, it means that x plus 1 minus y mod 9 should be equal to 0. Clear? So the case 4, whatever I was explaining, okay, till now, the case 4, if this condition satisfies, then it's a yes. If this condition doesn't satisfy, then it's a no. Clear? I think that this was an easy problem, and like the way I explained it completely with thoroughly, like whatever the steps are with a complete explanation, even if you are a beginner, I think it's like, yeah, you will get it right. Hi, 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 hi. I couldn't notice at the comment section for a long time because I was explaining. Okay, you did the same thing. Got it. So should we move on to B? Is A clear? Clear? One vote. Why just one vote? Anyways, people new over here, I will just request you guys to subscribe my channel and like this video so that I like get the reach. Okay, and yeah, subscribing, like you will get the up solving of the solution. So yeah, it's a win-win situation for both of us, right? Okay, so I'll just end the poll. So I'll just move on to B. Okay, I know it is finished. Okay, B is two large bags. You have two large bags of numbers. Initially, the first bag contains n numbers, a1, a2 till a of n, okay? While the second bag is empty. Visualize this. The most important part of a problem is to visualize it, okay? You have got two bags. Let's color it up. Okay, the first bag is green and the second bag is red. Why is it so? I'll just tell you why. Okay, so there was a little bit of lag. So anyways, like, yeah, you get it. Why is it so, okay? Why did I color it the first one green and the next one red? Because like the operations that is allowed for us to do is you can choose any number from the first bag and move it to the second bag. And then what you can do is you can choose, I mean not then, or you can what you can do, you can choose a number from the first bag which is also present in the second bag and then increase it by 1. What you have to do is you have to output yes or no based on the fact that if you can make the content of both the bags same. See, one thing that I don't know how many of, like how much you got about it, is that fact that let's say there are a few number map data structure in this. Okay, I think I forgot to go through the code of the first question, but yeah, it was clear for you guys, right? Anyways, yeah, map data structure, you can use map, but what did I use? Did I use map? I don't remember. Yeah, I used map, and I won't reveal it. First I will explain it to you guys. Okay, just hold it up. Okay, see, over here there are few balls. Okay, and this is empty. Okay, this is empty initially. Now what you can do is you can put this ball, one ball from here and put it over here. Okay, or what you can do is if you find that there is some ball over here and there is another ball over here which is having the same value, you can add 1 to it, the value of the ball. Okay, you can make the value of the ball plus 1. So one thing that why I made this green and red is the fact that whatever is in the green, I can manipulate its value. Okay, I can make it plus 1, or maybe if I make it plus 1, now what happens, whatever the value of the ball is, there is also another ball over here which is having the same value, so I can make it plus 1 again, right? So I can go on manipulating the value of green bag, but once it is in the red bag, it means that it is done, danger. I can't modify it anymore. Okay. And what do I need to do is, in the red bag I need to keep n by 2 balls. Okay, so just think about this very carefully. That is, I have to put from n balls, I have to put just n by 2 balls over here. And the moment I put a ball in the red bag, I can't manipulate with this value. Okay, that value becomes fixed. Now the question is how to solve it, right? Like, how many of you did solve it though? Like, I can remember that there was someone who told me I did too. I did too, yeah. Are you over there? Like, I forgot your name again. A B C D F G H. Are you over there? Dude, I'm having 2.1 subscribers, so less, man. Do subscribe my channel, dude. Walking so much on it. So, anyways, you use frequency map. Perfect. Perfect. Now, see, the most important thing. Okay, one more thing that you have to understand. Whatever ball you have over here in the green bag, okay, in the green bag, this Excalibur man, you can add one to it and then add one to it. You can go on adding one to it. Okay. There was something written in the question that a of I is lesser than equal to n, which means just the way he told frequency map. Yeah, you can use a frequency map over here. You can use the frequency map in the form of an array also. Okay. N is even, yeah. That is very normal. Like, obviously n has to be even, because if n is not even, you can directly say that no, it's not possible to have the content of both the bags same, right? You can directly say that. Yeah, n is even, right? It is given, I guess. Yeah, guaranteed that n is even. So this plus one plus one plus one, which means that if you are moving one ball from here to the red bag, it has to be the ball which is having the maximum value. Why so? Because let's say we have a orange ball, which is the maximum value ball over here, and the other balls, that is blue balls, are having a value less than orange, right? Now, if I don't put the orange ball in the red box, and if I put some blue balls over here, okay, if I put some blue balls over here, the orange ball can never, this orange ball, it can never match up the value of these blue balls, because you can only add one to the value of the balls. You can't subtract from them. Okay. So here comes the greedy approach. What is the greedy approach? Try putting the ball which is having the most value into the red box. Clear? Works. Now let's say there are two balls. There are two orange balls. Okay. That is, there are two balls which is having the maximum value. In that case, what we are going to do is we are going to put one ball over here. Okay. Which makes one orange ball over here, one orange ball over here. And since now we can see one thing, that both its contents, this orange ball and this orange ball, right? So both of the bags are having an orange ball, which means both of the bags have a ball which is having the value of some specific number, which is the maximum number possible. Okay. So in that case, what we can do is we can directly say that we can cancel out the effect of that. Okay, we can directly cancel out the effect of that. But what if there is only one orange ball, or maybe there is three orange balls? Okay, Remember one thing, when I'm talking about orange ball, it means the maximum value ball. Okay, the ball with the maximum value. So it may happen that there are three balls which is having the same value, and that is the maximum value. So that is what I mean by three orange balls. So in this case, you can put this one orange ball over here, and you can neutralize the value of this orange ball and this orange ball, but you're still left with one orange ball, right? So whenever there is an odd number of orange ball, okay, whenever there is an odd number of orange ball, which means that one orange ball is left over there, what will you do? You know that if you're moving it to there, you can't neutralize the value. But you also know one more thing. कितने क्वेश्चन किए? दो, not much. तीन थर्ड वाला कर रहा था, बट थोड़ा ये हो गया, थोड़ा टीएलई आया एक, इस पे एक पार्ट पे टीएलई आया, तो फिर मैं छोड़ दिया. Okay, so the green, about the green thing. Okay, where was I? Yeah, orange ball. So you know one thing, that whenever you're having one orange ball, we also know one more thing, that is the orange ball has to be moved to the red basket no matter what, because if the orange ball is in the green basket, you can't do anything to it. I just explained the thing of this orange and blue balls, right? That is, if you're having orange and some other blue balls, you have to move the orange ball to the red basket, not the blue balls. Why? Because the orange ball can never have the value of a blue ball. Because if the orange ball wants to have a value of the blue ball, it has to become decremented, not incremented. Okay, but we only support the incrementation of the values. Clear? So yeah, move one orange ball over here. Now all of these are blue balls, right? Now let's say once the orange ball moves over there, now it is not the maximum value ball in the green basket. So now it becomes a red ball. Okay. Now there is a new orange ball. That is, among these, which is the maximum value? So let's say this is the maximum value, right? So what we are going to do, we are going to put this ball also over here, right? That is what we are going to do basically, right? But let's say now there is a twist in the question. That is, if there is two orange balls, what should we do? As I was mentioning, like, yeah, as Georgit was mentioning, that yeah, you can move this one ball to over here and then cancel out the values of these two, right? Done. Nope. Now that is not the thing that you're going to do. You're going to move one orange ball from here. That is right. But you're not going to make this orange ball disappear. Okay. You're not going to cancel out this orange ball with this orange ball. Because you know one thing, that there is a red ball over here which is having a value greater than this. Now if you make the orange ball disappear, you can never make the red ball disappear. Right? You can never neutralize the effect of this red ball. Right? So what you have to do is you have to make this orange ball equivalent to the red ball. How can you do it? Since you know that there are two orange balls over here and here, and you have the opportunity that if you're having same values in both the bags, you can add one to it. Add one to it. Now what happens? You are just decreasing the effect of this red ball. Okay, you just decrease the effect of this red ball. How? Let's say the orange ball was having a value of 3 and the red ball was having a value of 5. Now what is the new value of the orange ball in this bag? It is 4, right? So you just reduced. 5 minus 3 was 2 and 5 minus 4 is 1. You just reduced it, and you have to reduce it. That is the most important thing. Now now another thing, okay, another very interesting thing. What if the value of the orange ball was 4 and the value of the red ball was 5, right? So once you make it plus 1, now it becomes 5, and now it has the power of the red ball. Okay, now it has the power of the red ball, and it can vanish the red ball. It can utilize the red ball itself. Okay, it just neutralizes the red ball. Now the orange ball is not there. Sorry, I erased everything. Now the orange ball is also not there. The red ball is also not there. But there is a orange ball in the other basket, which is now the red ball. Okay, which is now the red ball. How to neutralize it? Same method as I did earlier. Okay, the same method. Just go on doing it. So there are basically three steps that you have to do. If you notice one thing very carefully, like whatever I explained till now, आज बड़ा अजीब contest आया था. हाँ, right. So if you notice one thing, that whatever I have told, I can summarize. You want to see my profile? Can't reveal. No, just kidding. I'll show you my profile. Okay. Okay. So I don't know whether this is a thing called code clock. So this is my code chef profile. Okay. Sorry. I won't show you it on my screen. So this is my code chef profile where I have where I have a 4-star account, night batch on lead code, and specialist on Codeforces, and at coder I don't do that much. Okay. तगड़ा है ना resume? Peter Griffin. No, no. Like I have a account with Peter Griffin, which goes by the same name, Peter Griffin Codes. But that is not my profile right now. This is my profile, Georgies_codes. Because I am doing coding again, because as I told you that since I have not been. Yeah, you can add me on Codeforces. Yeah, obviously. You can add me on Codeforces. You can add me on LinkedIn. It's okay. It works for me. Yeah. Okay. We just मैंने last month देखा था last month. Okay. So see, मतलब अभी तक जो मैं समझा रहा था, did you see top ranks? Many of them are Indian. No, I didn't see the top ranks. ये सब ना मैं एंड में करता हूँ, ठीक है? ये सब एंड में करता हूँ, अभी नहीं. बी क्योंकि मैं ज्यादा तो एक्सप्लेन करूंगा नहीं, तो बी ऑलमोस्ट खत्म होने वाला है. सी सो फ्रॉम हियर what you can say that if we are going to make it step by step. Okay, now we are going to go step by step. First thing, whichever is maximum, ignore my handwriting. Okay, I think I forgot to follow my other device. Yeah, so whichever is maximum, move from green to red. Okay, move it from green to red. Clear? But there is a trick over here. That is, when are you going to move it? Now comes the second condition. Move it only if you can't add one to it. Add one to it. What do I mean by that? That is, there is no ball in the red bag which is having the same value as the green bag. I mean, whatever the ball you're noticing at, right? First thing, whichever is the, okay, I think I forgot to, whichever is maximum, by maximum I mean the orange ball. Okay, you can only update one ball after putting one in the other bag. I don't understand what you're telling. Okay, I'll just explain the whole thing. If you have any doubt, you'll just tell me. So whichever is maximum, that is the orange ball, move it from the green bag to the red bag. Clear? When to move it? Move it only if you can't add one to it. Okay, if you can't add one to it, move it. But what if you can add one to it? Is it like necessary that you can't move it? Yeah, it is necessary. No, I'm just kidding. You will, you will not. I mean, you mean you will not move it at some. Like now comes the third condition. That is let's say not third. I will say it was two of A, and this is two of B. Okay, that is two of A was move it only if you can't add one to it. But when will you add one to it? When it is logical to add one to it, right? Whenever there is a red ball over here, right? There is a red ball over here and there is an orange ball over here, then only you're going to add one to it. Because if there is no ball over here, that is the red bag, it is empty, and the green bag, okay, no, I don't mean no ball over here. So let's say if the red bag is having a red ball and the green bag is having a green ball, okay, and both of their values are same. So in that case, if you're going to add one to it, it is of no benefit, right? So you're going to add one to it only if you find there is a ball which is extra in the red bag. Okay, note this point. Add one if extra in red. Add one only if there is an extra in red which is greater than its value. Because if there is an extra ball in the red bag which is greater than the value of the specific ball, then only you have to make that specific ball having a value equal to that red ball, right? Equal to that value, right? You getting it? What is the case 3? Best case, check how many times. How many? Ignore my handwriting, okay? Check how many times you can add one, okay? How are you going to add one or why will you add one? Refer to the second point. When should you add one and when should you not? Refer to the first point. I mean, when should you add one and when should you like put it to the other box? Refer to the first point. And to summarize all of them, refer to the first and the second point. And what to do throughout the whole code, refer to all the 3 points. Okay. Is it clear? Tell me one thing. Is it clear? Most important thing. Okay. The most important thing is it clear? I'm so bad at it, I still can't understand the problem. You can't understand the problem as in you can't understand the question or you can't understand the solution that I explained. Anyways, people, if you think that I am explaining good, even if you feel that I'm not explaining good, subscribe my channel. Yeah. Subscribe it. Yeah, you guys are liking it. That's good. At the beginning of the stream, it was 2105, and now it is only 21. Sorry, it was C standing. How it is possible? What happened at standing, man? Oh, uh, division 2 is maximized for experts only, right? Or am I wrong? Rating of the Indian player. Yeah, these guy, na? This guy is, na? Okay. First, let me first tell me if B is clear or not. Okay, I won't. Like that we can do later on also. And we are going to do it. We are going to review the whole profile of all the people and let's roast them because even I want to get cancelled. Like Ranveer Alabadia got for Samaranas, India's got latent. You can explain 2 points. Yeah, sure. So why is my screen getting so laggy, man? Okay. Two, what I mean is that you have to move it only if you can't add one to it. Okay. So like moving has got various points. So first of all, what I told you that you have to move it whichever is maximum, right? You can move whichever is maximum. But then also there is one more condition that you are going to move only if you can't add one to it. That is the condition that I was explaining just now. That is, sorry, that is if there is a orange ball over here and there is a orange ball over here, right? So now this is the maximum, right? But should we move it? Nope. The first instinct that may come to your mind is cancel them out. Cancel these two out, right? But that is the wrong approach, as I just now told you. Because why would you cancel it up when you can add one to it, right? So that is what I meant. Add one if extra in red greater than the value. What do I mean? That is add one if you find that there are two orange balls and there is a red ball over here which is having a value greater than this orange ball. Okay. So what you can do is you can simply add one to it, right? So that you can make the value of this orange ball reach closer to red color. I mean not red color, red ball's value. Okay. So that you can make that orange ball red. So that you can neutralize this red and red. Because remember one thing, it is always a better approach to neutralize the red with the red rather than the orange with the orange. Okay. Because you can neutralize two oranges. But the next moment, neutralizing the red will be more difficult for you. So try neutralizing the maximum value that you're getting. I think it will be better if I explain you with an example, right? What I mean. The best example over where like everyone will be confused is this. Okay. So what I'll do is I'll just delete them, or should I do one thing? I'll just move on to the bottom of the page. Okay. So that everything gets vanished. So over here what we can do, can I control V? Yeah. Control V is working. Okay. You can see it. Now see what we are going to do with the bags. Over here what I have, 1 1 1. How many ones are there? 1 2 3 4 5 6 7. 7 ones. 1 1 1 1. Okay. And 1 4. Now what is the orange ball? Use Myro. What do you mean by Myro? What the heck is Myro? Okay, Myro.com. It is a collaboration platform. Okay, I have to. Yeah, I get it. I will check on it. Okay. Now see, what is the orange ball? 4 is the orange ball now, right? So what we are going to do, first of all, we are going to check, can we add 1 to 4? Nope. There is no ball only over here, right? We can't add. So there is no way of adding 1 to 4, simply remove this 4 and make it come over here. Now 4 is the red ball. Okay, let's say it's not the red ball, but it is the red ball because there is only one maximum value, right? It's the red ball. Now what is the orange ball? You can, for the orange ball, all of them are orange balls. There is no blue ball only. Okay, the best condition that you can have. All of them are orange. Why am I lagging so much? Okay. Okay. Now what I have to do is I have to check if I can add one to any of the orange balls. Nope, I can't do it. So I have to move this orange ball over here. Okay, which makes it like this, right? So there are two orange balls now. What is our main goal? Our main goal is to check if we can add one to any of the orange balls or not. Yes, we can do it. We can add one to any of the orange balls. We can add one to this. So what does it become? Now this becomes 2. It's okay, like I can go with this color also. It becomes 2. And this is the orange ball. Now which is the orange ball? All of them are orange ball. No. Now all of them are not orange balls because we have got a clear winner. So now all of these balls are going to be blue balls. Okay. Now what we are going to do is you're going to move this orange ball over here. Okay. Sorry. You're going to move this orange ball over here. Now tell me one thing. Which is the orange ball? All of them are orange ball again because now all of them are having the same maximum value. What we can do? We can add 1 to it. We can make it 2. Can we add more than that to it? Yes, we can do it because these two are having the same value. So we can make it 3 also. Can we add it more? No. We can't add more. Now put this ball over here in the red bag. Okay. Again the same thing. 1. Okay. 1 can become 2. 2 can become 3. 3 can become 4. And 4 can become 5 because there is a 4 4 over here. But will we make it 5? No. That is the condition that I was telling you guys. Okay. Sorry, I think I lagged a little bit. I'll explain it again. Okay. 1 can become 2, right? Then 2 can become 3, right? Then there is a 3 over here. So now 3 can also become 4, right? Even 4 can become 5 because there is a 4 over here. If you notice, right? But will we make it 5? No, because there is no value which is greater than 4 in the red box. So why would we make it, right? If there is no value which is greater than 4 in the red box, so we won't make it. We will rather neutralize them. Okay? How to neutralize this? Cancel both of them. So now we cancel this and this. Clear? Same thing goes for the remaining ones. 1 becomes 2, 2 becomes 3, and then you cancel the 3's. Okay? Now 1 becomes 2, 2 can become 3, but we won't do it because there is no value greater than 2. So we are going to cancel it. And there is 1 and 1, simply cancel it. So what is there in the green? What is there in the red? Nothing. I mean, yeah, there is something, but it is neutralized. So basically everything has been neutralized, which means the content of green and red is same. Is this concept that I explained till now clear? And how I did the last this example? Is it clear? If it is clear, then I move on to the code. Should I move on to the code? Clear, clear, clear. Okay, great. Oh, I forgot to put down a poll. Okay, so now how you're going to do it, right? How to do it? Let's move a little bit lower. See, one thing is very evident that we have to use maps, right? But about getting the maximum value out of the specific bag, what we can do, we can sort out the whole array and then put out the maximum values, right? But some condition, okay. So basically, let me just tell you like what condition we are handling and why we are using the specific data structure to handle that condition. So since over here in this box, it is all about finding the orange ball and then finding the orange ball, orange ball, orange ball, which means the maximum value. So we can do one thing, we can sort all the elements over here. Okay, we can sort all the elements over here and we can, from the maximum values, we can start the operations and then go on decreasing the values, right? So first of all, what we're going to do, we're going to sort the whole thing. Clear? After that, what we're going to do is we are going to put those values over here, then put another value over here, right? Now I just told you one thing, one edge case that we were facing earlier. Over here, if there is a 4 and over here there is a 4, but there is no 5 over here, right? So in that case, we won't make it plus 1, right? But how can we know if there is a 5 over here or not? Or if there is a 5 or 6, whatever, if it is over here or not. So for the red bag, we can't sort it, right? We can't sort the red bag every time we put some values over there. And we, in the previous example, you just saw that it doesn't mean that it is going to be put in a sorted manner, because at the beginning over there we put 4 over there, and after that we put 1, then we put I think then we put 2. So 4, 1, 2, not at all sorted in any order, right? So for this handling, whatever what which is the maximum element in the red bag, how can we find it? Priority queue. Okay, by using priority queue we can find out whichever element is the maximum in that red bag. And remember one thing, whenever we were cancelling, okay, whenever we were neutralizing, we neutralize the maximum value only. Okay, so it is also easy to neutralize them by just using priority queue dot pop and remove that specific element from the green bag. Clear? Nothing more. Yeah, that is it only. Like, yeah, you're done with it, right? Okay, so let me just show you the code quickly. I'm having an array, then I'm sorting it out, then I'm having a map. Why do I need a map? I need a map because I have to check whether all of them has been neutralized or not. Okay, so map is basically the frequency map as A B C D F G explained. Okay, so it is basically the frequency map, nothing more than that. You know that the value can never be greater than n plus 1, but this was not needed actually. I just later on realized that it was not needed. So what I do, I sort it out, and as I was mentioning, I move from the end to the beginning. Okay, and I check if that element is there in the map, or if that specific element is having a frequency of 0, because both of them mean the same thing, right? So if either of them satisfies, that is, that element is not there in the red bag. So one thing is very clear, move it to the red bag, right? Yeah, simple, move it to the red bag. But if that specific element is there in the red bag, which gives us the opportunity to add 1 to it, right? Which gives us the opportunity to add 1 to it. So we are going to add 1 to it, right? But what if that element is already there in the previous bag, right? In that case, what we are going to do is, if it is not there, while it is not there, I mean, while it is there, add 1 to it, and at any position, if you feel that you were not needed to add that, okay, you were not needed to add that, it is very simple. We just put check if pq dot top is lesser than equal to AR of I minus 1. What do I mean by AR of I minus 1? Because you can see one thing, that we were adding 1 to it until unless we found that it is not equal. So just as I was explaining you this, that is, if there is a 4 over here and there is a 5, if there is not a 5 over here, so what you're going to do is you're going to first move it, first make it 5, okay, and then check if pq dot top it is lesser than equal to 4 or not 5, 4. You're going to check it with 4, because only if it is lesser than equal to 4, then only you can have the 5. I mean, sorry, then you can't have the 5, right? But if it is lesser than equal to 4, I mean, if it is greater than 4, that is, if there is a 5 over there, okay, let's say if there is a 5 over there, so in that case, yeah, you can have the 5. Clear? In that case, you can have the 5. Or let's say there's some other condition also. Let's say if there's a 6 over there, then also you can have the 5. Okay. So in that case, you're going to pq dot pop, as I mentioned. Okay, pq dot pop, and make the map of that number as 0. Simple. Remove that from the green bag and remove it from the red bag. Neutralize them. Otherwise, what you can do is you can move it to the orange. I mean, not the orange, the red bag. Okay. Okay. So it is basically when you have to, like I just told you about the rules, the various rules. That is, check how many times you can add one. No, not this one. That is, if you can move it. Okay. So when till what position that you can take it, and then you have to move it. Because yeah, obviously the destiny of every ball is to be moved to the next bag, right? It either neutralizes or it moves to the next bag. That is what the whole question is all about. Now, when can we say that it has been neutralized? If the whole map is empty. That is, from 0 to n plus 1, all the values in the map are empty. Okay, that is, map, all the values are empty. Over here, what we are doing is, we are going to print no if at least any one of the value is not empty. That is, if there exists a map for that specific number and the frequency of that number is greater than 0, then only we can say no, we can't do it. Otherwise, it's a yes. So is the code clear with you guys? Should we move to C? Like, I haven't done C though. And I won't do C. Because I don't like doing it, man. Like, I can show you one thing, okay? Why can't I see my submissions? Okay, so after this, we are going to, yeah, C. The first C I submitted by Goncharo Mike. First, I have to myself understand it, right? Then only I can explain you, right? So see, first of all, I got a TLE in pretest to 10, and then I got a wrong answer. I mean, I was just messing up with the logic, okay? But the basic logic gave me a pretest 10 TLE. Can't help it. Oh, this guy is nice, man. He has been doing CP for a long time, and then he had a 642. Yeah, from 642, it is like. Okay. Goncharov Mike. Can I search anyone through this? I don't know. Oh, okay, okay. This guy, the guy at the ninth position. How do I find a solution? Okay, it's opening. Ah, separate. Okay, guys, just tell me, should I explain C and then go on with the rating of the problems, or should I keep it till B only? How many questions you have done on lead code? Uh, I don't remember. Like I have done almost, I guess, 400 problems on lead code. But I don't think that doing too many questions on lead code really matters. Like something like that. It doesn't matter that much. Why is it going with not B, not A? What is it? This? What is this question mark, man? This is C only, right? Oh, this is D. Sorry, I clicked on the wrong one. This is C. Man. Okay, let me just tell you what the C problem is all about. Okay, because he has done it really with very less number of lines of code. I think it is okay. I can explain it, I guess. Like I haven't gone through it, but I'll try to explain it. You're given a positive integer n in one operation. You can add to n any positive integer whose decimal representation contains only the digit 9, possibly repeated several times. What is the minimum number of operations? Blah blah blah. What do I mean by that? I'll explain it. Don't need to worry. There's a number called x. Over there, you can add, let's say, you can add 10 to the power y minus 1. Okay, you can add them. Now, the value of y is up to you. The value of y can be from 1 to 10, I guess. Okay, the value of y can be 1 to 10. Now, you can do this addition any number of times. One Now, what you have to do is you have to make any digit of x 7. That is your main aim. Okay, you have to make any digit of x as 7. Now, if any digit of x is already 7, directly you can return 0. I mean, yeah, directly you can say that is you need 0 operations, right? But if it is not so, that is where we have to think about. So since I am explaining through someone's code, I'll just go through what he has done. What is prov of n? It is basically while okay. So from this you can know one thing, that it is going to check, prov is going to check whether that specific number contains 7 or not. Okay. And here comes the solving. He's taking the value of n and answer is equal to 10. Why is it so? I'll tell you, because I think answer is going to be minimum. Yeah. Why is it so? I'll tell you, because the minimum value of number of operations that you have to make, it is way lesser than 10. Okay, it is way lesser than 10. Why? Because let's say in the first position, I mean the units digit, you can have from 0 to 9, right? Any number you can have. So if it's a 7, you can clearly say that you need 0 operations, right? If it's a 8, you can add 9 to it and it becomes 17. So you need one operation. For 9, add 9, it becomes 18. Add 9, it becomes 27. So you need two operations, right? Sorry, 0. For 0, add 9 and the last digit becomes 9. So there is a cycle. Okay, there is a circle if you notice one thing. So whenever you are adding 9 to a specific number, okay, so let's say you're starting with 9, you you're starting with 0, you add 9 to it becomes 9. You add 9 to it, the last digit becomes 8. Then it becomes 7, 6, 5, sorry, 5, 4, 3, 2, 1, and 0. So there is basically a cycle, right? So what is, like, if you move from 6, okay, if you move from 6 and you want to go till 7, so how many steps are there? 1, 2, sorry, 2, 3, 4, 5, 6, 7, 8, 9. So within 9 steps, you can move to 7. So minimum you need, I mean, sorry, maximum you need 9 additions of this, of 9 operations to satisfy it, right? So that is the reason he has taken 10, so that it is more than the maximum. Okay, got it. I can't prove it. Why is right? Okay. But what he has done is, I can tell you what he has done. Okay. He approaches the problem in such a way that he tells us that if you're having x, you can go on to add a specific number, let's say 9999. Okay. You add the same number only y number of times. That is what he's telling. Okay. It tells us that you go on adding the same number till you find that there is a 7 in that. Okay. Till you find there is a 7 in that, and whenever you find that there is a 7 in that, you can just tell that whatever is minimum, count or answer. Okay. And since we know, like, he has used a lot of number of zeros, but you don't need to use that number of zeros. You just need to, as I mentioned, 10 to the power 10. Okay. Or rather, I think he has also used 10 zeros only. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I think for safety he has used 11 zeros, but you can do it with just 10 zeros. So basically, he has went on adding 9 to x, okay, till he found a 7 in it. Then he has went on adding 99 to x till he find a 7 in it, and goes on doing it till 9999. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Till 9 nines. Okay. Till he finds the 7 in it. And among all of them, what he is going to do is he is going to tell whichever is the minimum. Now if you want to know what is the proof of this, don't know. I don't know. Rather, I felt that this was not possible. I was going to do something like this, but I felt that this is not possible. But now I feel that there are some cases where it is possible. Okay, because like what I felt was that this is not possible. Why? Because let's say if you're having a 6 over here and you're going to do 9999999, you will mail him, okay? 999. So what happens is, oh, from here he is going to have a carry of 1 over here, right? Just the way I was explaining in the first problem. A carry of 1 will always be there. So from that carry of 1, now this becomes 7, but this 7 plus 9, it messes it up. Okay, right? This is what I mean. But over here, if we had 9999 and this was 0, which means there will be a carry of 1, right? There will always be a carry of 1, and this 6 becomes 7, and we get the 7 for us, right? Now this seems to be very proper, right? Proper, appropriate, and this is the most appropriate thing. And this is what he has done. Okay, because you can either try making one specific position plus 1 till you get it, or you can make it minus 1 till you get it. Now from here I can think of a different approach. I don't know whether they will allow me to submit or not, but what I feel might work. Like if it works, you can mail me. Where did it go, man? Where did I do the C? Why can't I find the C? Two large bags, skibidus. What was the name of the problem, though? Devya. Okay, I can't find Devya. Yeah, I got it. Right, this one. Like, if it works, he just added 9 and count the. Yeah, I get it. Like, if this works, I have a very damn good thing about it. Okay, that is answer is equal to 0. Now, int d is equal to n mod 10. That is the last digit of that specific number. What you have to do is, if it's a 6, it means there will be 9 steps required. If it's a 7, it means 0 steps required. If it's a 8, no, if it's a 6, 6, 5, 4, 3, 2, 1, 0. That is how the cycle was going, right? Let me just comment it out and write it. If 6, then 9. If 5, then 8. Okay, let me write it like this only. If d is equal to 0, six, 7. I don't know whether this will get the right answer or not. If it gets the right answer, then I'll explain you what I did. And whatever I did, it will be a mastermind kind of thing. Okay? Which just clicked on my mind right now. If d is equal to 6, then answer is equal to 9, 8, 7, 6. Okay, n by is equal to 10. while, like, do you know what I'm doing basically? I'm doing some random stuff right now. 10 uh, plus 1111. This is going to be 11. I'll tell you what I'm doing. Okay, you don't need to worry. Eight. This is going to be 9 actually. This is 8, 7, 6, 5, 4, 3, 2. If it doesn't, what if it doesn't pass the pre-test only? Because it is taking a lot of time. Oh, sorry. N by is equal to 10. Run again, yeah. I know it will fail. Run again, man, run again, run again, run again. Now it should pass. I mean, not pass, but at least it won't give me a TLE. Now it failed. 4540. Why is the first one coming as 4? It was 51. 1. 5 can be. This is the phase that I don't want to stream actually. 5 is basically. 1 second. 4. 4. Why is it 4? 5, 6, 7. It's 2, right? So this is a 5. 5 is 2. Yeah. Well, I didn't mention only what is D. I didn't mention only what is D. Now it won't come. Yeah, it won't come. But now I got the idea that why. I don't remember whoever code you were telling me. Why is it right? Okay. Over here you can see that many cases will satisfy. This is 1 0 is satisfying. This 3 is satisfying. Like not many, yeah, not many. But a few cases will be satisfying. Now I get it, like why he has done it like that. Okay. It is because of this fact only. That is, at every specific step, you know one thing, that it is going to have a carry on of +1. Apart from the fact if the previous element is, apart from the fact that if the previous element is 1. Okay. The condition, this condition. 51 over here, 51 as it was. Okay. So if it's a 61 and if you add 9 to it, sorry, For this, there is a plus one, right? There is a carry. It works perfectly. But if it's a 60, in that case, if you add 9, it becomes 69. And like, yeah, it becomes a 69 and we don't have a carry. When it's a 69, there is no carry. Okay, how many people are watching it now though? Let me check. Name of the extension? CPH. CPH judge. Okay. And there is also another extension that I will prefer you people to use, Thunder Client. That is, if you want an alternative for Postman and if you want to hit request, so yeah, you can use Thunder Client. And CPH is for CP. Because what it does is very simple. Okay, I'll just show you with an example. So let's say if I'm solving this D, problem D, okay. So over here, if I press this, sorry, on D, if I press this, okay, so it tells me which language I want to code in, okay. And if I then enter, then I get this, okay. And apart from that, what I can do is I have a snippet for CP, which is basically looks like this, okay. But let's say if we are upsolving, let's say if we are upsolving and we find the D code of gone whoever it is, I don't know his name. So see, if I copy paste his whole code, okay, I copied and then I paste it over here. So basically, what I can do is over here I can check out whether it is satisfying or not, okay, for the given pretest that has been given in the question. So if it satisfies, over there you can see one thing, that when we were going for Devya Devyatkino, we saw that it was failing, right? But over here it won't fail, I guess. But I don't know why my compiler is getting a little bit slower. Okay, it shows it is failing because there may be more than one cases over here. Okay, so that is the reason why it is failing. But if you want to see a case where it passes, so it looks like this. Okay, no, not like this. Sorry, like this. Okay, not even like this. I'll just show you what it looks like if it passes. Okay, so it shows like this passed, and it also shows us how many time. I mean, how much time it took to solve it. Okay, 374 milliseconds, the runtime. And over here, as you saw that this D, it doesn't match with the expected output, but whatever he has done, it is right, it is perfectly right because he has got a accepted over there. So what you can do is you can directly submit it, okay. So if you submit it over here, and one more thing, it works only on Firefox, the submit thing, okay. The remaining thing, they work on Chrome as well, but if you want to submit it directly from this extension, then it works only on Firefox. So that is the reason you can see that whenever I am coding, whenever I am doing something, I usually use Firefox a lot. Because yeah, see, over here it is getting submitted. So now it is in queue. Click on it, running on test 10, which means that yeah, obviously it will get accepted. Move it, check it again. Actually, you can refresh it also. Okay, so there are a lot of test cases. So we won't be checking it. So this is a very good extension, I guess. You can use it. I think we'll get it with CPH judge. Oh, okay. It goes by the name Competitive Programming Helper. Okay, I think they have made some update because this looks more compact. I think this is an update from their side. Okay, so they have updated some features. Automatic compilation will display for compilation errors. Intelligent judge with support for signals, timeouts, and runtime error. Works with comparative. I don't know what it is. Cat is auto submit integration. So there is some auto submit, I guess. Works locally for your own problem. Yeah, support for several languages. I think they have modified the supported languages. Okay. And what you can do is you can contribute to this also by going to the developer guide. You can see it. It is basically a GitHub. Then you can create a pull request from there. If you're a developer, obviously you can give it a try. And it is made by an Indian guy, Devyanshu Agarwal, okay, which is great. So I think it's time to read the problems. Okay, let me read the problems. I don't know how many lines I've drawn. Okay, easy, medium, hard, very hard, medium hard, or rather not medium hard. Make it hard medium, hard medium. This is medium easy. This is very easy. Okay, good with the naming conventions. My LinkedIn it goes by my name only. Okay, you can search my name only. It goes by my name. So the first problem, not that easy, I will tell. But yeah, no, I will make it medium easy. Second problem was medium. I know that there was a lot of leakage in Telegram because of which, like, most of you got the solutions. But I mean, not over here. I believe that my subscribers are not that cheating, guys. C was C was actually easier than B. What I feel after seeing his solution. But if you want to get the proof of it, then have a knowledge about it, then I will tell that it was hard medium because like it's not easy to get the proof of it. Even at this point, like it took me time to get the proof why it is, and I am pretty much sure that if you go through my whole video quickly, you won't get it. What I mean, okay? So yeah, it will take you time to understand what he has done. But I mean, not time to understand what he has done, time to understand why he has done that. Okay, what is not the problem? Why is the problem over here? And other problems, not worth it. Because this guy has done one, two, three, four, five problems. This guy has done five problems. Damn. Anyways, that's it from my side. Should I end the video? Any more doubts? Quickly, quickly, quickly. If there is no more doubt, I will just end the video, man. It was very nice. Whenever I talk of leaving the video, I find that there is 11 people watching this now. When I'm about to end the stream. Anyways, people, what you can do is, who is watching now, you can rewatch the whole video and subscribe my channel. Subscribe. Have you done Catus or CP book? No, I haven't done it, but I, I don't know what is Catus only. Okay, it is also a CP thing. This is the first time that I'm hearing about this, like from that extension thing. Ad coder, I was thinking of doing, but Catus I haven't worked with. People who are watching the stream, just like the video, subscribe my channel. That's it. Okay. Okay, do you guys want to play some chess? Because yeah, we are done with the video. You guys want to play chess? Catus by Stephen Hallam. Or rather, I think no, the chess idea is not that good. It's already Hallam. The one who wrote CP Book 4. And you guys are doing a lot of CP, dude. Because for now, I think I have completely shifted to development. I'm doing CP a lot less these days. Tomorrow there is this code shift contest, no? I'll try giving that. And yeah, I will come live also after the post contest discussion. I don't know why there are so less subscribers on my channel. Only 2106. Man, make it more, dude. So what to do? Do we have anything else to do? Nope. End the stream. Yeah, I think I should probably end the stream because yeah, I have been doing streaming for a long time, and I have to like put the timestamp of the videos also because there are people who are yeah, there are people who will be watching it later. So yeah, that's it from my side. Thank you.